As he suggested, I'm Director of Technology at 3DLook. Okay, we've been around for 9 years, and well, today I'm presenting the overall technology on how we do things for 3D body scanning. As well, we take 2 photos, okay, a front and a side picture in A pose, okay. On any smartphone, any camera, basically any background, fully clothed, this up to a certain point. I'll explain later. Then we run some computer vision algorithms to scan the human body under the clothes. We basically fit a statistical body modeling, and we run some machine learning algorithms to create an accurate 3D body model. And finally, we extract over 80 body measurements and some body composition information as well. We can predict the weight and the BMI without the need of having any scales. So we can predict the body composition, the visual progress of 3D body models, see within time how their body evolves by losing or gaining weight, for example. Target weight 3D body visualization. So basically, we try to predict how the body is going to look in case of losing or gaining weight. The user is going to be guided into post-validation. So we basically try to show the main joints and simply show them in red in case something is failing. We have 42 internal rules so as to guide the user into the ideal A pose for the front and side pictures. We've collected data during these 9 years, mostly from the US and Europe, on our evaluation data sets, which are basically used for deciding our releases and improving our technology. We use over 5,000 participants, okay. We have more than 30,000 3D scans, which are used for a statistical body model. We have a hardware scanner, which collects more than 5 million points for each 3D model. During the measuring process, we collect 86 manual measurements. We collect some body composition data, try to vary the camera, so basically different sensors, different viewpoints, different pose, clothing, and the light conditions to be able to train our models the best way we can. Okay. Overall, our 3D reconstruction engine leads into an ideal A pose. So we have the front and side picture, or extracting a large number of semantic landmarks from the statistical body model that matches these projections. The skeleton, basically the pose, to be able to match the front and side pictures. Once we created this 3D body, we reconstructed the 3D body. We extract the typical linear and circumference measurements and some body composition. We are adding is to kind of keep track of how people gain or lose weight. So people can scan themselves. We basically save the scans in time, and they are able to compare and see how their body is evolving in time. We can engage the users into setting a goal. We try to predict what the body would look like whenever this happens. So this is our target to basically lose some weight, and this is where mostly the body part would change. Yep.